Greetings in this video lecture. In this video lecture, I'm going to discuss about the application of free body diagram, about the application of equilibrium, and about the application of force system while solving a problem related to engineering mechanics. I have taken a problem which was asked in GATE, and let's begin with this. Before I begin, I am Rahul Verma, who is working as Assistant Professor in Department of Mechanical Engineering at ABES Engineering College, Ghaziabad. So what is an equilibrium? Equilibrium is a system or a condition or a state in which a particle, I will be dealing with particle in my first lecture, in which the particle retains its state of rest or uniform motion until and unless acted upon by an external force. Okay, because it is a particle, so we are not going for the moment concept, but we are going only for the force concept. So what type of force system I am going to discuss? I am going to discuss about coplanar, and concurrent force system. So what is the meaning of the word coplanar? When all the forces are acting in a single plane, it is called coplanar. And what is the meaning of the word concurrent? Concurrent means all the forces either converge or emerge from a single point. Okay. So let us take an example. If all the forces emerge from a single point and they all lie in this white plane, then the force system is called coplanar concurrent force system. For coplanar concurrent force system, the condition of equilibrium are sum of all the force in the horizontal direction and sum of all the force in the vertical direction are 0. Now, what is the concept of free body diagram? The concept of free body diagram has to be understood. It is one of the most fundamental things. What is FBD? It is a situation where we isolate what we are studying from its surrounding, and then whatever force are acting on that system, we draw all those forces acting on that system by the help of arrows. These arrows are in the direction, they are aligned along the direction in which the force is acting. So the angle between them will work, will give us the idea about the component and all that. So next, come to our topic. This is the question which I have brought for you. This was asked in GATE 2016. A rigid ball weighing 100 Newton is suspended with the help of a string. The ball is pulled by a horizontal force F such that the string makes an angle of 30 degrees with the vertical. So let us first draw the diagram of this situation. So if this is the point from where the pendulum is suspended, and this is the vertical, at an angle of say 30 degrees, this bob is pulled, okay? And this angle is given as 30 degrees. So what they are asking, if the weight of the object is 100 Newton and if the thread is inclined at an angle of 30 degrees with the vertical, what is the force? So what type of force system is this? This is a coplanar concurrent force system. How can we see that? To understand the concept, let us first draw the free body diagram. If this is the object and this arrow will represent the direction of force applied on the object by the wire or the thread by which it is hanging. This is the direction of the applied force F, and the weight of the object will act in the downward direction. W. The angle by which this is inclined, this angle is 30 degree. There are two ways of solving this problem. The first method is to find the component of the force along the horizontal and the vertical direction. And then, because the system is in equilibrium, equate it to 0. Okay, we'll start with this. So there are two, let us first resolve this force. The resolving part, I'm drawing it here. F is the force, W is the weight acting on the object in the downward direction. The tension in the thread is divided into two ways. First one is in the vertical direction. I'll call this one as T cosine of theta, and this will be T sine of theta. Component is always cosine, remember, because we are working in a rectangular or Cartesian coordinate system. The trigonometrical consequence lead to a component of sine theta. Okay. Now apply the concept of equilibrium. So when we apply the concept of equilibrium, the first equation is sum of all forces along the horizontal direction is 0, taking right side as positive. Okay. So if you write the equation, it will become F minus T sine theta equals to 0, or F equals to T sine theta. The second equation which we have is sum of all forces in the vertical direction is 0, taking upward as positive. So T cos theta minus of W equals to 0. From this we get W equals to T cosine of theta. Okay. If we divide these two equations, dividing 2 by equation first one, what we will get? T sine theta is F divided by T cos theta is W. From here you can easily see F can be written as W tan theta. Now we know the values. W will be 100 and tan theta is tan of 30. So this will become 100 into 1 upon root 3. And if you solve this with the help of a calculator, you will get 57.73 Newton. Now, in place of resolving the force, can we use some other method? Because this is a coplanar concurrent force system, we can go for Lami's theorem as well. I would request you all to solve this problem using Lami's method and match the answer with the answer which I have suggested to you. For this video, I have used this book and you can consider reading this. This is one of the best books for this subject. Thank you very much for watching this video lecture.